All right, hello everyone. My name is Irene.
My name is Harry.
My name is Anika.
I'm Tremi.
I'm Hanishi.
And today we're going to be talking about Kruskal's algorithm, which is an application of graph theory in computer science. All right, so first off, what is a graph? A graph is a set of objects or vertices that are connected to each other with certain relations or edges. So a graph is made up of vertices and edges. So what is a vertex? A vertex represents the objects in a graph, and it's often depicted by a circle or dot. It's also referred to as a node or point. And here we can see circled in red, those are the vertices. Next, what is an edge? An edge represents the relations between vertices, and they can be directed or undirected or weighted or unweighted, or any combination of those. They're also referred to as links or lines. Here are some examples of different relations. And which we will talk more about later on.
And the is Anika, and the loop is also called self-loop, which is an edge that connects a vertex to itself. And here are two examples. The left one is simple graph, which is a graph without loops and multiple edges and cannot contain any loops. So the loop on this picture is unavailable. And the right one is pseudograph, which is a graph can contain both multiple edges and loops. And this is the available example. And the adjacent vertex, which is the vertices are adjacent if two vertices in a graph are connected by an edge like the upper one, and otherwise if there aren't any edges, there aren't any edge between the vertices, which is called non-adjacent. And the directed graph is also called digraph, which is a graph in which the edges have a direction. As the examples show, there is an edge between vertex A and C. Here is an arrow which makes the edge have a direction, and this edge also called arcs. And the second one is weighted graph, which is a graph in which each branch is given a numerical weight. As we can see, here are a lot of numbers between the edges, and this also makes it to be a special type of label graph in which the labels are numbers.
And this is the example of the algorithm that we're talking about. And like in the picture, I show the vertex and the edge. And in here, there are 9 vertex and the 13 edges. And so what's the purpose of this is this algorithm is to find the shortest path between the vertex, and so that we can reduce the cost in real life situation. And also the number between the number just above the edges are the weighted number that is that can be represented as the cost. And this is so what is a tree? A tree is the branch in a graph in which any two vertices are connected by exactly one path. And a tree with n vertex has n minus 1 edges. And like in the picture, the leaf, there's a leaf in tree, and the leaf have exactly like 1 degree and cannot exceed 1 degree. And here the purpose, I have shown the example of the graph and the real life application is from road network of pipes, phone lines, internet cable, electric grid, and so on. And the way it works, the way how we find the shortest path is to step from the less weighted to the greater one. And whenever we find the cycle path, we just ignore it. And finally, we get the shortest path available, and which will give us the high efficiency in performance. Okay.
The history of the Crossing is Joseph Carter is the found Joseph Carter was on January 29, 1928 to September 2010. He is an American mathematician, statistician, computer scientist, and psychometrician. He was known for running for a being attached to a naval art important concept. For example, cross algorithm. He discovered this algorithm while he was a second-year graduate student at University of Chicago. There are 4 steps for all the business of the application. First step, solve all edges in increasing order of their edges rate. Step 2, pick the smaller edges. Step 3, check if the new edges create a circle or loop in the springy string. The last step is if it doesn't for the circle, then include the edges in FSD. Here is the example of the basis for the applications.
What is the requirements? The only requirement of the Krosko algorithm is we need to have the connected weighted graph in order to find the minimum spanning tree. And this is the example of the connected weighted graph. For the applications where Krosko algorithm is generally used is to lay out electrical wiring, TV network, or a network of pipes for drinking water or natural gas, or computer network such as LAN connection, electric grids, tour operations, or landing cables. And this is our references. And thank you for watching.